So this material will still be on this unit that we're doing here. So we've got, so far we've worked a little bit with exponents. We've worked with order of operations, but we need to go a little bit further with exponents, okay? So far what we've learned with exponents is, just the basics. So if this is 3 squared, this is you can either call it a root or a base, okay? And this is your exponent right here. And this is what we've worked with so far. And we learned that when you do that, you're just squaring it 3 times itself, okay, which is 9. You're not doing 3 times 2, okay? Then we learned about, well, what about a negative number that's got an exponent? So like -2 squared, okay? And we learned what to do with what happens when there's a negative squared. And that was negative times itself, which is -2 times -2, which is 4. Okay, positive 4. Then we looked at, well, what if it doesn't have the parentheses and it's squared? Well, if it doesn't have the parentheses, all you're squaring is the 3. So that's 9. And the negative's still there. Okay? So that's as far as we got with exponents, was just the basic exponent and then what to do with negative numbers that are squared from there or have an exponent. Now we need to look at a couple things. One of them is, what do we do when we multiply numbers that have exponents? Okay. What do we do with numbers that have exponents inside of parentheses and then have an exponent outside the parentheses? And then we need to look at negative exponents. And I've showed you that where I put, like, instead of this being the negative, up here is the negative. So those are a couple things we need to look at with the exponents still. Let's take the first one. Let's say it's 3 squared times 3 cubed. Okay, remember what I talked about? What was the whole reason? Do you guys remember what the whole reason why we use exponents in math? I said math was kind of like a language, and we use exponents to do what? You remember? Do we do them just to make students mad and add a little?
To make sense.
Okay, they do make sense once you learn them. We're writing them to make them shorter. Okay, because otherwise you're going to have really long numbers with lots of zeros and really big numbers. It's kind of a shorthand. It's to write these out shorter. Okay, so that's why we use these exponents, is to shorten it. Otherwise we'd have all these really long problems, all these really long things. So when you've got this, okay, when this would creep up in actual math is when you've got numbers that you are working with that are really big, but yet you're multiplying times each other. Okay? So what this looks like, if I was to write this out, not shorthand, it would look like this. 3 times 3, which is this part, right? Times 3 times 3 times 3, which is this part. Right? That's what it would look like written out in long form. So what is this in short form? Put it all together. 3 times 3 times 3 times 3 times 3. How many 3's is that? 3 to the 5th power. Okay? So this is shorthand. This is writing it out longhand. This is going back to shorthand. So that means, do we have to write it out every time? No, that's what we're trying to avoid. We're trying to go from here to here.
So are we multiplying the exponents?
Okay, well, let me ask you, is 2 times 3 5?
No, it's 6.
That's 6. What is 2, what would you do to 2 and 3 to get 5? Add it. Okay, that is the shortcut shorthand. Is if you are multiplying exponents, if you add them, the exponents, you get your answer. Let's try another one.
Okay.
4 to the 7th times 4 to the 3rd. What do you think that is? 4 to the 10th power. Pretty easy, right?
4 to the 10th, yes.
Now, it is easy right now because you know to add. What gets hard is when you get further into the test and you got to remember that rule. Like, do I add them? Do I? So write in your notes to put, when you're multiplying exponents, when you're multiplying numbers with exponents, you add the exponents. This is called product of powers.
So the base always stays the same, you don't never touch, like.
Correct.
change
That's a very important point. For one, to do product of powers,
You said the multiplying with exponents what?
when multiplying numbers with exponents, you add the exponents. But Tiana brought up a very important point. Okay, and that is that the base stays the same.
Can you say it again?
Let's see,
When multiplying numbers with exponents, you what?
you add the exponents.
Okay.
So what Tiana brought up was, well, the base stayed the same. This only works is if your base is the same. Okay, let me show you why. If I had this, okay, if I had this where the bases are different, I can't do this rule. Because which base would you choose, right? Is it 5 to the 6th power? That's not what this is. Let's write this out. Is that 5 to the 6th power? Nope. Is that 3 to the 6th power? Nope. That's not 6 3s. So you can't do this unless the base is the same. So if the bases are different, you can't do this rule. You cannot add the exponents. The product of powers, you have to have the same base. Okay? But when you do have the same base, that's what makes it work. That's what makes it where you can just add the exponents. Because you're keeping your base the same. Okay? You're keeping your base the same and you're just adding the exponents. Okay? So let's spell this one out and see if we're right.
Are we ever gonna have a problem like that?
Oh, yeah.
No.
Especially when we get into x. So here's this one, right? I spelled it out. There's 7 4s. 1, 2, 3, 4, 5, 6, 7. And then I'm still multiplying these 3. So here's these 3. Here's these 7, right? Everybody see that? I have 7 4s. I have 3 4s. So how many 4s do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4 to the 10th.
How did you get that?
Well, 4 to the 7th, 4 to the 3rd.
Mm-hmm.
What's your notes say? When multiplying things with exponents, you just add the exponents.
Oh, okay.
7 plus 3 is 10. But the base, this right here, has to be the same number. Cannot be one of them be a 5 and one of them be a 3.
So you just went with the bigger number? Like for the top? Or how'd you get that number?
I just added 7 and 3.
Oh, okay. Okay.
Yeah, just added 7 and 3. Just like the rule said, like the thing you wrote down, when multiplying numbers with exponents, both these numbers have exponents, you add the exponents, 7 and 3. That's where I got 10.
Oh, I'm stuck on that problem up there. I thought that problem was towards that problem.
Yeah, this one can't work because this is a 5, this is a 3. You can't add the exponents when the two bases are different. Okay? Now, where this comes into play a lot more often later on is when we're dealing with like letters. So like x to the 3rd times x squared, okay? And we're dealing with like x's or even y's, like y to the 5th times y to the squared, y squared.
Isn't it honestly just the same thing?
Same thing, keep your base the same, x, then you add your exponents, 5. Down here, y, add your exponents, 7. But if it ends up being x cubed times y to the 4th, can't do that anymore. I can't make it combined because they're not the same bases. They got to be the same bases. Got to be the same bases. We could do it here. We could do it here. Can't do it here. Okay? right, so I'm going to keep this one up here. This is called product of powers. Okay? That is the rule. Product of powers. Product means multiplication. Remember that was in our vocab. So when we're multiplying things that have powers, that have exponent, power is exponent, right? Something to the 5th power, 6th power. When multiplying things with powers, this is the rule. Okay? Here's a different one. Well, let's do this one first. Let's switch to division. Okay, so let's say I have 3/5 over 3 squared. Okay, 3/5 over 3 squared. Now here we were multiplying, right? Product of powers. But here we're dividing.
But wouldn't it still kind of be the same?
Well, what do you think? Do you think we're going to add the exponents? So do the exact same thing as multiplication?
No.
No. Instead of adding, what do you think we do with the exponents? We subtract. Okay, up here, because we're multiplying, we're adding. Down here, we're going to subtract the 2. So what would 5 minus 2 be?
3.
3 to the 3rd power. And if I were to spell it out, right, write it long form, 3 times 3 times 3 times 3 times 3, that's 3 to the 5th, right? We all in agreement there? This is 3 to the 5th. And then 3 squared would look like that, right?
But we don't have to write it out like that, right?
No, but I'm showing why it works that way. Okay, and if you forget, this is where it helps.
Oh.
What if you're on the test and you forget the rules? Do I add? Do I subtract? Well, you can always go back to long form and remember which one it is. Okay, so here it is in long form. Well, what is any number divided by itself? 1. Well, if you have 1, that doesn't change anything. Those cancel out. What about 3 divided by itself again?
1.
1. So those cancel out. What are you left with?
3.
3 to the 3rd power. Okay? You can do it with x's. X to the 5th over x to the 4th. Okay? So you got x times x times x times x times x over x times x times x times x. Only 4 of them. These cancel out. You're left with a single x to the 1st power. 5 minus 4 is to the 1st power. Okay? And we don't write to the 1st power. We don't have to. We just, it's 1st power. Okay? So when we're multiplying, we add the exponents. When we're dividing, we divide the exponents. Okay? All right, sorry. When we multiply, we add the exponents. When we divide, we subtract the exponents. But what happens, here's what happens when you're doing the division. Okay, we did 5 minus 2, right? Right, we did 5 minus 2. What if it's 4 to the 2nd power over 4 to the 5th power? Now, right, actually, let me change this because we did 2 and 5. Let's do to the 6th power. Okay, so here we did 5 minus 2 and we got 3. Well, let's do the same thing here. What's 2 minus 6? What is 2 minus 6? 2 minus 6 is? I'm hearing 4, but is it?
4.
Well, wouldn't 6 minus 2 be 4?
Yeah.
What is 2 minus 6? It's not positive 4, it's negative 4. You got something to the negative power. Can we have that?
Is it possible to have that?
It is. You know, I've been alluding that we're going to have negative exponents. This is when it happens, right? We did it right. We did the problem. We're not wrong. Okay, we did 5 minus 2, we got 3. We did 2 minus 6, we got negative 4. Okay, well, I can't leave it like that though. We're not wrong, but I can't leave it like that. Okay? Let's put this in long form and see what we end up with. I think I need one more, right? 1, 2, 3, 4, 5, 6. 4 squared over 4 to the 6. Everybody see where I got that? 4 squared over 4 to the 6. Well, let's do our same thing. These cancel out, right? These cancel out. Now I've got nothing on top. I can't leave nothing on top. Okay, so I've got to put a 1 there. Because that's what 4 divided by 4 is 1, 4 divided by 4 is 1. So I got to put my 1 there. Okay, it's on top of the fraction. And what am I left with down on the bottom of the fraction? 4 to the 4th power. So it looks like this. 1 over 4 to the 4th power.
Why did you put a 1 there?
Well, because you can't leave a fraction with nothing on top. Let's all agree on that. You can't leave a fraction with nothing on top. It's not 0 because 4 divided by 4 is not 0. 4 divided by 4 is 1. Same thing here. 4 divided by 4 is 1. So that's why I put the 1 up here. It's a whole 1. So if you look, I've got 1 over 4 to the 4th. Well, this is what this turns into. Okay, all you do to turn any number that has a negative exponent, instead of going through this whole thing and having to mark out and do all this, is to make it a positive exponent, you put it at the bottom of a fraction, and you turn that positive. See what? That's what we did here. We put a 1, we put it at the bottom of the fraction, and we turn the 4 positive. So let me put a couple examples up there and have you do them real quick. Turn this. Turn this one. And turn this one. Put a little trick in there. Turn those 3 into this.
I don't know.
Okay, follow what I said. Put it on the bottom of the fraction and change that to a positive 2.
So a 1?
Yep.
Okay, mine definitely looks like 52, but it's 5 to 6.
Yeah, make sure the 2 goes up above. Keep it an exponent. It's still an exponent. Okay, same thing here. Put it at the bottom of the fraction, change that to a positive. Not any math involved.
Just do it?
Just do it. As Nike would say. Like, does Ashley have Nikes on today? Oh,
No.
I was looking. I think I'm Adidas today. No, I'm Puma, Adidas, and Nike. That's funny. And Under Armour. That's funny. I'm representing all the brands. So I'm trying to be a PE coach that includes all the brands in there.
-2 to the negative 4.
Okay, so this one, same thing. Put it at the bottom of a fraction, but change the exponent to positive. So I put it at the bottom of a fraction and I changed the exponent to a positive. Doesn't change the rule. Okay? So when you go to work these out, that's where I was saying, Ashley, that you can't just put these in the calculator because it's going to give you 1 over 25, 5 times 5. And it's going to give you 1 to whatever 3 to the 7th power is. I can't do that in my head. That'd be 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243, times 3 is something bigger, 720 something, times 3 again, so too big. And then this one is going to be 1 to the negative 2 over the fourth, okay? Now, it is not in a parentheses, so you would only be taking 2 to the fourth. That's getting kind of deep into the woods. Okay, we'll stop there. That'd be 2 times 2 times 2 is 8 times 2 is 16, so it'd be negative 16. But just so you know, you put it at the bottom and you change the exponent to a positive. Okay? One last thing, and the reason why I'm going to go ahead, I know I'm pouring a lot in, but it'll be on video so you can go back and watch it, is
there a certain name or rule for this one?
well, product of powers, then we did division of powers.
Right.
This is negative exponents,
Negative exponent.
okay? And then this is going to be called power of powers. Power of powers. So we had product of powers, now we're going to do power of powers. This looks like this. Let's say it's 2 to the third, okay? 2 to the third, which do you notice that the exponent's inside the parentheses? Right? You see that? 2 to the third, the power is inside the parentheses. But then I'm going to put a exponent out here. Okay? So do you see the difference between these two kind of problems? This one, you are multiplying two things that have powers. Okay? This, you have a power of a power. Okay, you're not multiplying, there's no multiplication there, right? It's only power of a power.
Okay, now isn't that 3 an exponent also from the 2?
Yes.
Okay.
But here's where I want to see the difference. This is not like this, where you're taking 2 to the third times 2 to the fourth, and you add them and get 2 to the seventh. This is a totally different problem than what this is, right? This would be 2 to the third, that's a 3, times 2 to the fourth, which we would do 2 to the seventh. That's what we just did over there. That's not what we're doing here. This is taking 2 to the third and multiplying 2 to the third 4 times. Right? Anytime you have a power, you are taking it times itself 4 times. So written out in long form, it looks like this. I wish I wouldn't have chose such a big number. So this is this one, this one, this one, this one. How many 2's is that? Can you count them up? Let's do it together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2 to the 12. What would have been a shortcut to get 2 to the 12? Not add the exponents, that's 7. What gives you 12 out of that? Multiply the exponents. Do you see that? I didn't add 3 and 4, I multiplied 3 and 4. So if I have 3 cubed,
So you multiply the exponent.
3 cubed to the 5th power, that would give me 3 to the 15th power. Okay? So that's the difference between these two kinds of problems. This looks like this, and we're going to get more practice with it. But I want to go ahead and get it on video. You can go back and watch it if you need to. But this one, you're adding the exponents. This one, you're multiplying the exponents. Okay? And when you do division, you're subtracting the exponents. All right, lots of rules. We'll get some practice with it tomorrow. And then we're building towards getting another test in. And so from there, we'll let me go ahead and stop this.
So what will all be on the test?
Well, we've got